Right now, as you're watching this video, a spacecraft 8.8 billion kilometers away just detected something that shouldn't exist. It's measuring more light in empty space than all the stars and galaxies combined can account for. Scientists call it the optical background excess, and it's completely unexplained. But here's what will blow your mind. This discovery is coming from a probe that was supposed to shut down 7 years ago. Instead, it's rewriting our understanding of the universe. By the end of this video, you'll understand exactly how a mission designed for one quick photo of Pluto became humanity's most distant active explorer, and why what it's finding right now might be the biggest mystery in astronomy. Let me put this in perspective. If Earth was the size of a marble, New Horizons would be 58 kilometers away. That's like controlling a smartphone in the next city using smoke signals. Every command we send takes 8 hours and 14 minutes to reach it. Every photo it sends back takes another 8 hours to reach us. We're literally communicating with yesterday. And here's the kicker. Its nuclear battery is dying. We have maybe 10 years left before it goes silent forever. So right now, at Johns Hopkins Applied Physics Lab, a small team is racing against time. Because what New Horizons is discovering in its final years isn't just changing textbooks. It's revealing that space itself might not be what we thought it was. Today, we're going to answer 3 questions. How did a piano-sized probe survive longer than anyone imagined? What did it find that has scientists scrambling for explanations? And why does this matter for the future of humanity? Picture this. It's January 2006. NASA has spent $700 million on a spacecraft, and they have exactly 23 days to launch it. Miss that window, and Pluto, their target, will be unreachable for another 200 years. Why? Because Pluto was literally escaping. Its elliptical orbit was carrying it away from the sun, and its thin nitrogen atmosphere was about to freeze and fall like snow onto the surface. January 17th. First launch attempt. Scrubbed. Hurricane force winds. January 18th. Second attempt. Power failure shuts down the entire launch complex. The team is starting to panic. Every day they wait, Pluto moves 4.7 million kilometers farther away. Then, on January 19th, with the window closing, they get their shot. At 2 p.m. Eastern, New Horizons doesn't just launch. It leaves Earth faster than any spacecraft in history. How fast? It passed the Moon's orbit in just 9 hours. Apollo 11 took 3 days to cover the same distance. But here's where it gets really clever. Even at that insane speed, it would take 14 years to reach Pluto. Too long. The atmosphere would be gone. So they aimed for Jupiter. Imagine you're on a skateboard and you grab onto a speeding truck. When you let go, you're moving way faster than before. That's a gravity assist. But Jupiter is surrounded by radiation that can fry electronics in seconds. The dose New Horizons would receive? 10 million chest X-rays worth. February 28th, 2007. New Horizons threads the needle, close enough to steal Jupiter's momentum, far enough to survive. And because scientists can't help themselves, they turn the cameras on. What was supposed to be a simple flyby became an impromptu science mission. The gravity assist worked perfectly. New Horizons left Jupiter traveling 23 kilometers per second, cutting 3 years off the journey to Pluto. Then came something unexpected. New Horizons went to sleep for 8 years, not broken, hibernating, using just 12 watts of power. That's less than your laptop charger. Every few months they'd wake it up, check systems, download data, then back to sleep. Mission Operations Manager Alice Bowman called it the loneliest job in the solar system, watching over a sleeping spacecraft billions of kilometers away. But in December 2014, everything changed. December 6th, 2014. New Horizons wakes up for the last time. Pluto is 6 months away. As it approaches, something unexpected appears in the images. A massive bright region shaped like a heart. This wasn't in any model. Pluto was supposed to be a dead, cratered ice ball. Instead, it had geology, active geology. But here's the terrifying part. They had one shot. New Horizons would scream past Pluto at 14 kilometers per second. The entire encounter would last less than 24 hours, and with a 4.5-hour signal delay each way, they couldn't steer in real time. Everything had to be pre-programmed. July 14th, 2015. The day we met Pluto. For 22 hours, New Horizons went radio silent. It was too busy taking photos to talk to Earth. The wait was excruciating. If anything had gone wrong, a cosmic ray hit, a debris strike, a programming error, the mission would be over. Then, at 8:52 p.m. Eastern, we have signal. New Horizons is alive. And the images, my God, the images. Pluto's heart, officially called Tombaugh Regio, was a vast nitrogen ice plain, actively churning and flowing. Mountains of water ice 3,500 meters tall. Blue atmospheric haze in 20 distinct layers. Evidence of ancient lakes, maybe even a subsurface ocean. In 24 hours, Pluto went from a pixelated dot to a complex, dynamic world. But here's where our story takes a turn. New Horizons was moving too fast to orbit Pluto. It was already leaving, heading into the void. The mission was officially complete. They could shut it down, save money, celebrate and go home. Instead, someone asked, what else is out there? Secretly, they'd been using Hubble to search New Horizons' path, looking for anything, an asteroid, a comet, anything it could visit next. They found something. A mysterious object called 2014 MU-69, later named Arrokoth, but reaching it would require burning precious fuel. Arrokoth was 1.6 billion kilometers beyond Pluto, floating in the Kuiper Belt, a region of ancient ice and rock left over from the solar system's birth. But here's the dilemma. Every drop of fuel spent reaching Arrokoth meant less ability to maneuver later. They had to nail it perfectly. 4 precise engine burns in late 2015, each one just a few meters per second. Together, they bent New Horizons' path toward this mysterious object. 3 years later, while Earth celebrated New Year 2019, New Horizons made its approach. What they found defied all expectations. Arrokoth looked like a cosmic snowman, 2 spheres, gently connected. But this wasn't cute. It was revolutionary. This showed how planets begin. Not in violent collisions, but in slow, gentle dances. 2 objects orbiting each other, gradually spiraling together until they kiss. And the surface? Virtually unchanged for 4.6 billion years. We were looking at a perfectly preserved fossil from the dawn of the solar system. After Arrokoth, there were no more targets, but New Horizons kept going. And that's when things got weird. You see, our sun creates a bubble in space. The solar wind, charged particles streaming outward, pushes against the interstellar medium, creating a boundary. The Voyager probes crossed this boundary, called the heliopause. But they only sampled 2 points with 1970s technology. New Horizons is taking a different path with modern instruments, and it's seeing things that don't match our models. The solar wind isn't fading smoothly, it's lumpy, turbulent. Like the edge of our solar system is breathing. It's detecting more dust than expected. Tiny grains, probably from collisions in the Kuiper Belt, creating a haze we never knew existed. But here's the biggest mystery. In 2021, scientists used New Horizons to measure something no one had accurately measured before. How bright is empty space? They took images of empty sky, subtracted all known stars, subtracted all visible galaxies, subtracted zodiacal light from dust. Something was still glowing. There's twice as much optical light in the universe as all known sources can explain. It's like walking into a room, counting all the light bulbs and realizing the room is somehow brighter than it should be. Scientists are scrambling for explanations. Unknown populations of faint galaxies, decaying dark matter, something else entirely. And here's why New Horizons is perfect for solving this. It's far from the zodiacal light that pollutes measurements near Earth. It's humanity's clearest window into the true darkness of space. But we're running out of time. New Horizons is powered by plutonium-238. Every year, radioactive decay reduces its power by about 4 watts. By 2030, they'll start shutting down instruments. First the camera, then the particle detectors. Finally, just the radio transmitter will remain. The team has shrunk from hundreds to dozens, but they're determined to squeeze every bit of science from this dying spacecraft. Every day could be our last, Alice Bowman told me. We check the signal strength each morning, hoping it's still there. And the data keeps surprising them. Just last month, they detected unusual patterns in the solar wind that suggest the heliosphere might be shaped differently than we thought. Instead of a sphere, it might be shaped like a croissant or deflated beach ball. We simply don't know. But here's what makes this urgent. The discoveries from New Horizons are already shaping the next generation of deep space missions. NASA is planning an interstellar probe for the 2030s, designed specifically to study the boundary of our solar system. It will launch knowing what New Horizons found, avoiding its limitations. Private initiatives like Breakthrough Starshot are planning tiny probes that could reach other stars. They're using New Horizons survival strategies as a blueprint. But that excess light mystery, it could revolutionize cosmology. If we're missing half the light in the universe, what else are we missing? Right now, today, New Horizons is still out there, still measuring, still sending data that takes 8 hours to reach us. A mission planned for 9.5 years has lasted 18 and counting. A probe built to photograph one world has explored 3 and is now mapping the edge of our solar system. Unlike Voyager's golden records, New Horizons carries no message for aliens. But in a way, it is the message. Proof that humans can build machines that refuse to stop exploring. So what have we learned? A piano-sized spacecraft, built to last a decade, is approaching its 3rd decade of operation. It turned Pluto from a dot into a world with a beating heart, showed us how planets are born, and now it's revealing that space itself holds mysteries we never imagined. The question isn't whether New Horizons will eventually fall silent. It will. The question is, what will we discover with the time we have left? And perhaps more importantly, what will we build next, knowing what we know now? If this story of human ingenuity and cosmic mystery fascinated you, subscribe for more deep dives into the missions pushing the boundaries of human knowledge. Because out there, in the darkness between our sun and the stars, a small piece of human engineering is still exploring, still surprising us, still refusing to give up. And that might be the most human thing of all.